Hi all. Thanks a lot for joining. I see many people here already. So we can give 1 or 2 more minutes for others to join. Let me share my screen as well. I hope you all had a chance to take some time off because we gave 3 weeks summer break and many people are coming back from vacations. As usual, while we get started with the meeting, if you could record your attendance to the our HackMD document, that would be great. And we will slowly start our meeting with the agenda. Thanks again for joining. Today's agenda, we start with a presentation and demo on binary authorization from David Bandori from Google, which is a good and interesting topic to restart our meeting series. And David will talk about what they are doing when it comes to binary authorization, and we will hopefully see some fun demo. And we will also see if demo, monsters are with us or not, if the demo works or not. And then our next topic will be about a reminder or heads up around the new initiative. The community started talking about CDF reference architecture and how we could contribute to that effort. So a few reminders about the discussions we had since the formation of the Special Interest Group Software Supply Chain, and then how we could align our efforts with the reference architecture work stream. But before I hand it over to Dave, I wonder if anyone wants to introduce themselves, because I see many new faces or new names with us. Should we do that? Perhaps, so we get to know who is with us. David, would you like to go first?
Actually, I was going to suggest that I go last right before I start presenting.
Oh, yeah, we do that. Then I pick the next person in the list. Alex Mistorp, would you like to introduce yourself?
Hey, yes, my name is Alex. I work on Cloud Build, basically also where David himself works. And I was interested in his talk, so I'm joining today.
Thanks, Alex. And Brett, did you introduce yourself in one of the previous meetings? Might have done that.
Maybe I guess I did, but I'll just do it real quick. So I'm Brett Smith. I work at SAS. I'm primarily architect on the on our supply chain pipelines, and I've been talking about nothing but security since last year. So super fun.
Thanks, Brett. And Charles, would you like to go next?
Yeah, I'm also at SAS, another architect on Brett's team.
Thanks, Charles. Welcome. And Chuang, I see you next.
Hello, everyone. My name is Chuang. I'm from Google as well. Same team as David. I work, but my team is particularly working on the open source security side. Thanks.
Welcome, Chuang. And Eric, I see you next.
Hey, I'm Eric. I work, Eric Wimmer. I work at SAS, also with Brett Smith and Charles.
Welcome, Eric. Happy to have you with us. And Jill is next.
Hi, I'm Jill Madrich. I'm from SAS as well and work with Smitty and that group and interested in learning more about the security in SASA.
Thanks. And Scott is next.
Sorry, I couldn't find my mute button.
That happens.
I'm at SAS too, working with Brett, Charles, Eric, and Jill.
Welcome. And I see Sue Johnson. Next.
Hey, can y'all hear me?
Yes.
Oh, okay, sorry, I was having I'm still having difficulties. Anyway, I put in the chat, I'm a project manager at SAS, and one of the teams that I support is the Salsa supply chain next gen pipeline team. So you've already met Brett and Charles and Jill and Scott, and Eric. So I'm part of that posse.
Oh, thanks. Welcome. And Tim.
Hey guys, I'm Tim Miller. I'm CEO of a company called Pusari. We work on supply chain security. Work with Mike Lieberman, who I think you might know. Yeah, so I'm here on behalf of us.
Welcome, Tim. And Yong Swan. Maybe you have problems with audio.
Sorry, I was just muted.
Okay.
I'm from Google. I work for the Tecton team, also with David and Prakash.
Thanks, Yong Swan. Did I miss anyone?
You missed me.
Oh, Tracy. Yeah.
That's okay. I'm Tracy Reagan. I am the CEO of and co-founder of Deploy Hub. I work on the Ortelius governance catalog, which is an open source project under the CDF, and I'm also on the OpenSSF board as well as the CDF TOC.
Thanks, Tracy. Thanks, Tracy. And anyone else wants to introduce themselves before we move on? I think.
Hi everyone, I'm Rajat. I'm from Jenkins X, the GSOC mentee. Yeah, it's first time joining here. Just interesting to know about supply chain security.
Welcome, Rajat. Okay. Anyone else who is joining first time to our meeting?
Yes. Sorry. Okay.
Hi, I'm Cara Delamark. I work at the CDF. I've been in this meeting before, but I haven't been recently. So very nice to be here. See you all.
Welcome, Cara. Osama.
Yes, I'm Osama Magdi. I'm from Jenkins X. I'm a GSOC contributor at Supply Chain Security. We look forward to improve security of our supply chain in Jenkins X.
Welcome, Osama. Okay, so if everyone introduce themselves, maybe David, it's your turn now.
Sure. Hi, everyone. I'm David Bendori. I'm the engineering manager for the Tecton team at Google, and I'm giving a presentation today. If you can release that screen share, Fatih, I will be happy to share my screen for the presentation. Now, there we go. Okay.
Yes.
So just to expand my introduction just a little bit, I have been at Google for a little over 7 years. As of Monday, I will be focusing full-time solely on Tecton. Until from Monday until now, I will call it. I have been the engineering manager for Google Cloud Build, which is our hosted build in the cloud offering at Google. I'm going to talk today about binary authorization for Borg. Binary authorization for Borg, one caveat I needed to add, sorry. I am a Google engineering manager, but please note that I'm speaking today on my own behalf and not on behalf of Google or Alphabet. These slides that I'm presenting have been approved for external presentation, but they have not been approved for public distribution. So I won't be sharing the slides. Obviously, the recording will continue to exist. Okay. I'm going to be speaking today on binary authorization for Borg. Google has released a white paper on the topic. In the white paper, we describe Google's code review process, how we collect provenance, and how we go about enforcing certain standards, including security standards. We generally speaking are focused on a specific enforcement risk and a specific enforcement check with binary authorization for Borg, and that is insider risk. The idea that I, as a Google engineer, could maliciously inject a payload into a Google product or service that causes that service to do something on my behalf that is not appropriate, in violation of our commitments to our users, possibly in violation of the law. Think of things like the SolarWinds hack, as it's commonly known. So as a company, Google has a very strong security focus, and we have many measures in place to limit our what we call insider risk. I think that's a common term many of you are likely familiar with. The hacker that we are concerned about, yes, we're concerned about external hackers, but really when we talk about binary authorization for Borg, we are talking about the internal hacker. We're talking about me, who is a Googler, who for some reason decides to act maliciously, and I have all of my insider knowledge that I'm going to bring to bear on trying to attack some Google system. And our goal with binary authorization is to prevent a Google employee from accessing user data without proper authorization. So when we interact with user data at Google, there are a couple of different roles we might play, and I'll lay them out here. We're not actually going to end up talking about all of them. First one is an end user. I'm a Google employee. I'm also a Gmail user on my personal basis. So I might authenticate directly against some Google service to see my own user data. I should not be able, as an employee with my employee credentials, to access even my own personal user data from my personal account. So that's what I'll call the end user access that Google employees use all the time. We're not going to be talking more about that today. The second access is I, as a Google employee, access user data as part of my role. So you can imagine the Google Cloud Build team gets a bug report from one of our customers. That customer authorizes us to do some debugging for them. We might access customer data as part of that debug process. And you can imagine this with any Google product. We do have standards around that, including two-party authorization before we can access customer data like that, access transparency reports that give our customers insight into what we looked at when we were using that access. But that is legitimate access that I'm doing as part of my role. That is, again, not our topic for today. Third kind of access, part of a service programmatically. So you can imagine Google Cloud Build has to do a whole lot of things on behalf of the user, but it does this using automation accounts of various kinds and might access an individual user's data as part of that, but no human sees that access or can observe it. We might aggregate user data to provide aggregate metrics and statistics to keep the service up and running smoothly, to ensure our users are having a positive experience and so on, but access to individual user data as part of the normal functioning of a service is not logged and tracked. So the white paper on binary authorization for Borg focuses on the threat model from the third scenario. I, as a malicious employee, inject a malicious payload into my own service in order to provide me inappropriate access to user data, i.e., I have abused my power in some way. So I want to give an understanding of how we developed a solution for this that limits that kind of programmatic access to user data by the service itself. But first, you have to understand how a service runs at Google. So the basic process looks like this. A developer authors some changes to the code. At Google, we have a large mono repo. You can read about that in other white papers. The fact that we have a mono repo very much works to our advantage here, because it means that there is a single choke point where we can access all code reviews and have an immutable record of exactly who requested the code review, who approved the code review, et cetera. Our code reviews at Google include inspection from at least one other engineer beyond the author, sometimes 2 or even 3 other engineers, depending on the standards for the code involved. Once that code is checked in, it's built. We use a build system internally that's similar to the open source Bazel project, which we are big contributors to and supporters of. That does a standard compile to create a binary. The build system actually runs in an isolated, locked down, hermetic environment. Employees can interact with builds in the sense of kicking them off and canceling them, but we are unable to access the build time environment. And that's going to become very important down the line in ensuring our software integrity. The build needs to be verifiable. That means it produces a build manifest, something that's commonly called, one piece of that is commonly called a software bill of materials. Another piece is commonly called a provenance. Our builds produce signed certificates that describe exactly the source that went in, cryptographic hashes of any binaries or built artifacts that came out. What were the build parameters used? What were the arguments used, etc. That manifest can be used to trace to provide an audit trail to the binary, from the binary all the way back to the source code that was used in its creation. And by extension, we can then follow that to the process that created that binary, the submission of the source code, where did the approvals come from, and so on. Once that artifact is built, it can be deployed to our production infrastructure that's known as Borg. It runs in something called a Borg job. If you're familiar with Kubernetes, it's a very similar model. The deployment happens in a container format. That Borg job includes configuration that specifies the requirements for the job, the packages to run, runtime parameters, flags, arguments, etc. And that Borg job now runs as an identity independent from the human users, and it can interact with other jobs in production, including accessing user data. The interactions between those Borg jobs are typically RPCs, and the job is provisioned with specific cryptographic credentials that I, as a developer, cannot access under normal circumstances. Those credentials identify the job, provide an identity for the job to use when making these requests from other services. So that's what the production looks like. That's what the production environment looks like. Let's look at the threat model that binary authorization for Borg addresses.
Hey, David, can I ask a question before you get too far?
Of course. Is that Tracy speaking?
It is Tracy. I'm curious about two things. You said you generate, one of your work products from the build is an SBOM and a provenance report. Can you share the data elements that you use in the provenance report?
I don't know if I'm allowed to share them. They're certainly internal. I don't know if we've released them, but what I can say is that the SALSA model, if you're familiar with that, is very well aligned with what we do internally at Google.
Okay, so if there's if you could find out, you don't have to tell us what your data is, but if what those data points are that you're storing in that provenance.
Sure, I understand. You're asking what the proto looks like or what the YAML looks like as opposed to what the values are. I understand.
Exactly. And I'm curious what that offers above what the SBOM is providing you. And are you using SPDX or are you using Cyclone?
None of the above. All of this infrastructure at Google predates any of these open source standards. And so we are not currently using any of those.
Okay, so that kind of, so it's probably more of like a build audit with another report that shows the provenance is what I'm guessing. I'd love to see what those data elements are that you're collecting. And one of the reasons why I asked that question is because, as you well know, we are starting to talk about a reference architecture.
Yes.
We have the CD events and understanding where the data elements and where they're coming from and what you're calling them, because vocabulary is becoming more and more of a, I would call it an issue for us. It would be super helpful to see how you're referring to that information.
Understood. If someone is taking notes, please, can you make an AI for me to follow up on that for Tracy and for everyone? I'll find out exactly what I'm allowed to share. I really don't know offhand, but I do stand by my statement. Broadly speaking, SALSA is very, very well aligned with what we're doing internally at Google, albeit, different formats and perhaps even different naming conventions. We're certainly taking lessons we have learned from doing this internally at Google and using those lessons to help provide good industry standards in these open source initiatives. I'll also add, before I go back to the slides, I'm working in a split screen environment here for the presentation. So if you raise a hand and I don't see it, by all means, just chime in like Tracy did. Tracy, I'm assuming your hand is up from your, okay, there we go. All right, so continuing onward. So the mission of binary authorization for Borg is to ensure that production software and configuration has been properly reviewed and authorized, especially if that code can access user data. So to achieve that mission, we have a deploy time enforcement service that looks at those deployment manifests before the Borg job stands up and makes a determination as to whether or not this job is even allowed to run. It verifies that the binary meets certain requirements at deployment time. So you can imagine, for example, an enforcement that says salsa must exist, or salsa must meet the following standards as examples of this. I'm going to show an example a little bit later on. Code change changes the binary, and in order for the change in the binary to take effect, it has to be deployed. So it has to go through this deployment gateway. So some examples of deployment checks. It was the binary built from checked in code as opposed to code on a developer workstation. You can imagine that as part of my developer workflow at Google, I constantly build in progress code that has not been checked into the repository. And I may even deploy that in what I'll call a developer environment that we want to allow. But if I try to deploy that in production, that we want to block. So there are different gateways for different deployments. We would ask, is the binary built verifiably, reproducibly? Is it built from tested code? What was the testing suite, code coverage standards? Have all the tests passed? Is the binary built from code that's intended to be used in the deployment, as opposed to, did other code sneak in here in some way? Every Borg job at Google has a policy. And so, for example, a Borg job like that developer job that I talked about that has no need to access any real user data, it has a policy defined, but might have no requirements. In other words, the policy is an empty policy. In contrast, a production job that runs Gmail will have very strict requirements because of the user data sensitivity involved.
I'm sorry, it's me again. I'm so sorry. This stuff I can talk about all day, so
Me too.
I apologize ahead of time. So on your build, on the build process itself, do you have a way to enforce or restrict, I should say, particular directories that the build can pull code from? And do you do that at the time that the compiler reads the file?
So the answer is yes, but not quite in the way you're describing. In very simple terms, what happens at build time is the first step in the build is walk the graph out to the leaf nodes of all the sources and gather all the sources in what I will simply call an appropriate place. Once those sources are in an appropriate place, the entire build context is sealed hermetically, so that there can be no outreach to a source repository or to an artifact repository, anything like that. So all
I guess the question I'm asking is, how do you enforce what directories you can go and gather from?
That's enforced in the source gathering up front.
Okay.
So
great.
it's not enforced at compile time. At compile time, we're already in a hermetic environment.
So you say these are the places you can go get this code. You can get it, you pull it down, collect it into your build directory basically, and then lock that build directory down.
Yes. Are you familiar with Tecton, Tracy?
I am. Mm-hmm.
Okay. So you can imagine that in Tecton, I have a source fetch step, maybe git clone, and then I have a build step, maybe Canico. And so I'm going to have different policy enforcement depending on which container is running and what it's doing. And my policy enforcement for that git clone might control where it is allowed to clone from.
Okay. And does that get defined in a build script that somebody writes? Or is it
it's defined in a policy enforcement file. I'm going to show you some of this when I get to the—
great. All right. Okay. Thank you.
Sure. So it's funny, I thought you were going to go here, Tracy, with your question. And I was going to thank you for giving me the softball pitch. One of the things to think about here is that the systems and the components that enforce the binary authorization itself, they need to be tightly controlled. So there's a bootstrapping problem here, right? That whole build environment has to be built in a way that we can enforce the standards and know that the build environment itself has not been compromised. All right, so there are several different enforcement modes for binary authorization, and this becomes very important when you're trying to figure out how to set this up and run it in your organization for the first time. The first is deploy time enforcement. I will call that single shot enforcement, meaning at the time that I say to deploy an artifact, it is checked against the policy, which makes a determination as to whether or not it can be deployed. The second mode is deploy time audit, which means audit all deployments, record what action you would have taken, make your determination, record it, but allow all deployments to go through. You might call this a dark launch. You might call this failing open. That enables us to turn on binary authorization for a new proposed service and see what it would be doing, allow it, but then develop a policy that will enable us to lock it down. You can imagine that as part of this bootstrapping problem that I described, you probably need to do something like this with your build environment in order to figure out what to allow in and what to block. That is an iterative process. Finally, there's a continuous verification mode. So you can imagine that I want to make sure that I have not deployed any assets that have the log4j vulnerability. I discover that late one Friday afternoon, let's say. And so I add a new policy that says asset may not be deployed to production if it has this Java package installed. Well, continuous verification will go through all the production jobs and provide a continuous verification that they are aligned with that policy. Depending on how I set that up, it could take the production job down if it's a serious enough vulnerability, or it might just audit and alert me as to where that vulnerability lives in production. Just to set expectations here, I've got 3 more slides and then I'll go to a demo. So there were several new features developed to implement binary authorization, including some emergency response procedures. The audit mode itself was developed as part of the transition. The way we got here was to first make the business case for the benefit and why we needed to do this. At Google, the talk was about reducing insider risk, robust code identity, and simplified compliance for when we needed to do audits and provide audit trails later on, we would have them all in place already. With regard to reduced insider risk, this was one of the primary drivers behind our development of binary authorization at Google, to prevent any single individual from obtaining unauthorized access. Binary authorization does not ensure that a group of individuals could not do this, but of course, having a group do this is harder to coordinate than the single rogue engineer who is able to do this on their own. Robust code identity, so the Borg jobs run it as an identity to certify their identity before gaining access to user data. There are other services that can't enforce the use of that data and so have to trust that job identity. So binary authorization ties the job's identity to specific code, indicating that only this code can be run in that job with those privileges. And that allows a transition from the job identity, i.e. trusting the identity and any of its privileged human users transitively, to code identity, so that we trust that a piece of code was reviewed and that its specific purpose is approved. And the last one was simplified compliance, as I mentioned. Previously, we had to do lots of manual compliance checks. Now that can all be automated, placed into dashboards, and so on. As for the tactical implementation, these are some steps that you might want to take to get here in your own organization. I'll just pause for a minute rather than reading the slide out to you. Notice in particular that last bullet point, a story for managing third-party code, is critical here. If you are taking in open source dependencies, do you know that that code is valid and that it adheres to your standards? And how do you go about verifying that? We, of course, have a story around that as well at Google. So binary authorization is an internal system at Google. We also have now provided this as a product on Google Cloud Platform. That's what I'm going to be demoing for you in just a minute. It's tightly integrated with Google Kubernetes Engine. That's our Kubernetes offering. And binary authorization allows you to apply a policy to your Kubernetes cluster that will provide these kinds of deployment checks like we've been talking about. It supports signature verification, image whitelisting. You can whitelist images by repository, by path, a particular set of digests. You can set policies at the project level, the cluster level, even the namespace level. And finally, there's a break glass functionality that has audit and audit trail associated with it, i.e. if you break glass, what you do in that break glass mode is fully recorded, so it can be audited later. That's obviously for emergency production access, which is obviously a production need in the real world. These are a set of links that you may want to follow up on to learn more. Those links are also available in the meeting notes from this meeting. I will call out that demo of binary authorization on Google Cloud link. That's to a personal repository of mine. And that's you're going to see that in action in the demo I'm about to show. If I can just ask you to be patient with me for just a moment. Okay, so hopefully you are now seeing my smiling face on GitHub, and I'm going to roll this demo. This was pre-recorded just in case. My name is David Bendori. I'm the engineering manager for the Tecton team at Google, and I'm going to give a demo today of our binary authorization offering on Google Cloud Platform, which is our externalization of binary authorization for Borg. Everything you're going to see in this demo today is available in open source. If you go over to github.com/Bendori, you'll see that I have a repository there called Tecton on GCP. That repository contains scripts that can be used to set up a GCP project exactly like this one. These are the scripts that I used to set up and even run this demo. And that will enable you to set up a similar pair of clusters in a Google Cloud project and play with Tecton chains and attestations yourself. So here I'm at my command line. I've set up my GCP project already. And as you can see here, I have got 2 Docker images already pushed to my repository. The repository is named my repo. One is cleverly named allow, and the other is cleverly named deny. I used a Tecton task run to build an image called allow. That image was signed by Tecton chains, which also created an attestation attesting to the provenance of the image. In contrast, I built the deny image using a local Docker build and pushed that image to the repository. It has no associated provenance or attestation. I'm going to now create deployments for each of these on my Kubernetes cluster. One deployment for the allow image, which I will call allowed, and a second deployment for the deny image, which cleverly I will name denied. Now, when I look to see if these deployments are in place, what I find is that the allowed deployment is ready, it's up to date and available, whereas the denied deployment is not. The reason for this is binary authorization. If I look at the events on my Kubernetes cluster, I see events for pulling and pulled the allow image, whereas there's an error for setting up the denied deployment with the deny image, which says there that no attestations were found that were valid and signed by a key trusted by the attestor. Let's go have a look at that in the Google Cloud Console. So here we're in the Google Cloud Console for the same project. And if I go and look at my Kubernetes clusters, I have 2 clusters up. One is called prod, one is called Tecton. The Tecton cluster is where I built these images using Tecton. Here's the prod cluster. And you can see on the prod cluster, if I scroll down to the security section, I have binary authorization enabled. Let's go look at the settings for that binary authorization. It's under the security area, cleverly named binary authorization. And when we look there, we see that we have a policy in place for this project. The policy for GKE cluster US Central 1.prod, which is our production cluster, says that we will only allow deployments of images that have been approved by all of the following attestors, and it lists the attestor that we used to attest to our image. If we go look at the workloads on the cluster itself, we see our two deployments here as two workloads. One is the allowed image, which was allowed to be deployed. The other is denied image, where you can read the error there at the end of the error, the last line, well, starting at the penultimate line. No attestations found that were valid and signed by a key trusted by the attestor. This deny image that I tried to deploy was built by a nefarious developer in this case, who did not use our standard build chain to build it, and so did not have the attestation in place, certifying that this image was deployable in our production environment, in contrast to the allow image, which was built using our standard Tecton tool chain and therefore had the needed attestation in place. So that's what I've prepared for today. I do have I do have that project still standing up. If you have questions about it, I could go live and head over there and show you whatever it is that you want to ask about. If you have questions about other parts of the presentation, happy to try to field some answers, and otherwise we'll move on with our agenda.
One question I have is, what's your process for rolling out additional requirements to your policy?
That's a great
that it doesn't break the world.
Sure, that's a great question, Justin. So what we'll typically do internally, and I've actually been through this several times since joining Google, what will typically happen is the binary authorization team will send an announcement of some new policy that's coming. They will deploy that policy in a dark launch audit only mode, and it will on a per job basis, it will record violations of that policy and send the job owners details about those violations. The job owners can then decide how that policy is going to be applied and enforced on their jobs. At first, that will probably be an explicit opt-in for early adopters. And then at some announced date, people will opt out of the future enforcement. And then the future enforcement will be on by default, except for people who have opted out of it. So there's a sort of gradual rollout process like that happens. You can imagine doing this in your organization with Salsa as you climb the Salsa ladder. So today you might enforce only deploy assets with Salsa level 2, and tomorrow you're working your way to Salsa level 3. So you're going to keep a policy in place that enforces level 2 with blocking deployments, and you're going to start auditing violations of Salsa level 3 so that you can figure out where those violations exist and how to mitigate them. Make sense?
It does. So once folks have opted out, do y'all, I'm just curious, do y'all have a process by which you're like, great, you can opt out until such and such a time, and then really go do it?
Yeah, as you can imagine, that's situation dependent, right? There are situations where a team can decide to opt out, and that's fine with manager approval, or maybe to opt out, they need director level approval, or maybe there's a deadline, or maybe in an extreme situation, a new policy is just imposed across all of Google and there is no opt out. It depends on what's the vulnerability that we're trying to mitigate.
That makes sense. Thank you.
Sure. Any other questions, please?
So I've got a couple. It was a really cool demo. Thank you. Who's the attester in this scenario?
You know, it's funny. I did a dry run yesterday, and I thought, oh, I never showed who the attester is and how that works. So give me just a minute here. Let me go over. Actually, let me share the screen. So I half anticipated your question, but didn't really prepare for it by changing that presentation. Let's see, which cluster do I want here? That's my key. Okay, so here is my setup of a demo project, very similar to the pre-recorded demo, which was using different projects because I recorded that last week. And if we, whoops, didn't mean to go there. Sorry about that. If we go over here to security and binary authorization. So this was the policy. I showed that in the demo. What I didn't show was, well, what does that attester look like? So the attester, so you can imagine, again, there are different roles of people involved here. So the attester, that is put in place by someone I will call a security engineer who sets up what the standards are. So this attester said, you must have an attestation that is signed by this key. And now as a security engineer, I can control access to that key And that will determine who can provide an attestation to your artifact and who cannot. So your artifact must be accompanied by an attestation that has a signature verifiable with this key. So I'll just go over here for a minute. So you can see that this key lives in a project. You can see the tail end there. It says keys in the name of the project, whereas the project I'm in up here, it ends in demo. Otherwise, these are similar projects. So here I am in the keys project, and here is the key. So the way I set this up for the demo is that I have a separate keys project from the other project. In the real world, you might in fact have, I put Tecton and Prod in different clusters. Very likely you actually have them in different projects and if you're on Google Cloud. In this case, I put the key project separate. You can imagine that only security engineers get access to this keys project. And then what we do is for these individual keys, oops, wrong place, we set up permissions. So you'll notice here that I gave this Tecton Chains controller account access as a crypto operator for this key. That Tecton Chains controller account is the build time service account that signs the artifact and provides the attestation for it. If we go back over here to the quote unquote production project, which is technically also my Tecton project, and we look here at all of the principals that exist on this account. So this builder is the build time service account itself. This Tecton Chains controller account is the one who had access to that key. So if you're familiar with Tecton Chains, the way this works is there are different workspaces as part of my Tecton setup in Kubernetes. The Tecton Chains workspace is not accessible by people who have access to the default workspace where I do my builds. So the builds take place in the pipelines workspace where my Tecton pipelines are installed. Tecton Chains watches those builds. It has a separate service account that is not accessible at build time. That service account sees that the container image got pushed, signs it, provides an attestation, uploads the attestation. So I also have to have security controls into that Tecton Chains namespace as to who can get access there. Because if I can get access there, I can get access to the service account. If I can get access to the service account, I can get access to the key. If I can get access to the key, I can create an inappropriate attestation. You can imagine I only have one attestation here that I showed. And this attestation is effectively saying, was this artifact built using my Tecton pipeline that I have set up here? And that's the only thing I did. You can imagine that I could have dozens of these attestations. Was it built using a particular pipeline? Are there certain critical vulnerabilities that have been mitigated? Is there a prevention of certain critical vulnerabilities? Have I attested that these critical vulnerabilities do not exist in the binary artifact? That's what I'm trying to say. I.e., this attestation set is here and signed only if the log4j vulnerability does not exist in this artifact. And you can have a whole series of these that might in fact be signed with different keys and enforced by different teams, and the policy determines which ones apply. So hopefully Brett asked that question. Brett, did I answer your question?
Yeah, you did. And then, so where are your attestations being stored in this scenario?
So the attestations are being stored right here in that deployment project. But I do have control. Oh, I'm sorry. The policy, I went to the policy. The policy is stored in this project. The attest stores are set up in this project. The attestations are stored in two places. This is part of your Tecton's Chains setup. I'll actually set up here. The short story is when I configured my Tecton Chains, in that configuration, I told it where to store them. Let me think here of how to get there. I need my config map. Where do I want to go here to get my config? Secrets and config maps is where I want to go. Okay, here it is, Chains config. So you can see here, I'll give you the YAML. That's not helpful. Here. So I've configured the task run storage, that's the build provenance, to store in 2 places.
Okay.
FAS and OCI, and I have also, there are 2 signatures that are involved here. I've configured OCI storage to go to Grapheus and OCI. So we can see those here in Artifact Registry. I'll just show you the OCI storage. If you are familiar with container analysis at Google, oops, sorry about that. If you're familiar with container analysis at Google, that's the Grapheus storage is in the container analysis API. This here is Artifact Registry. This is where my Docker images are stored. This was the image I created. This is the allow image. You can see it's labeled here. Here's the latest. That's the image that was built and pushed. And these 2 OCI bundles contain the attestations. You can see one is a signature ending in .sig. The other one is the attestation ending in .at. And the tags on those actually match the tag of the image that was built. So in this case, I stored them right alongside the image. I could store them in a different OCI registry. And in addition to that, I've configured it here for storage in container analysis. If you look at the Tecton Chains configuration, there are at least 2 or 3 other backends that are supported for storage of those attestations and signatures.
Cool, thank you. One last quick question, and you don't have to answer it if it's a really, really long answer, but what do we do about key management, like when we rotate keys?
Key management is a long and complicated story. Actually, as part of setting all this up, I had a long conversation about that with some of our internal folks. I'm sorry, Brett, I'm simply going to say to that one, it's complicated. The quick answer is that over here in that security section under binary authorization, so what I can do here is, if you look at my attest store, it's got version 1 of the key. So I wanted to rotate that key. If I have a security breach and I need to immediately revoke things that key has compromised, that's things that key has signed because of a compromise, I could just delete this attest store and it will no longer allow, this attest store will no longer, validate signatures, right? In the real world, if I'm doing a rotation, what I probably do is I create a new key version 2, I create a test store with version 2, and then over time, I sunset and delete that version 1 attest store. I might take some other steps along the way, but it's a complicated story today, and it's a manual story in binary authorization today, at least for our external offering of this.
Thank you.
Sure.
That answered everything. Cool.
Hi, it's Tracy again. Thinking through how you put this together, are you relying on a monorepo?
So for this, no, there is no reliance on a monorepo whatsoever. This entire demo was built using Google Cloud Platform and open source. The code I built happened to come off GitHub here in one of my own personal repositories, meaning the code for the demo is in GitHub, and I built a container, that allowed container is also set up there. Oh, actually, there's a second container that I built that I didn't talk about in the demo, which is—
So when you go farm the source, because I'm still thinking about the question I had earlier, when you go farm the source, you can specify what repos you want it to farm it from in a list or something?
Yes.
Okay.
In a simple case, you could create an allow list. These are the allowed places where you can go fetch source.
Okay, great, thanks.
Obviously, in the real world, there's a lot more subtlety than that.
Tracy, you had asked earlier about what the provenance looks like. I shared in Toto, which has a spec for provenance, and I shared a couple of those examples back up in the chat. And then for anybody else, if you're not using Kyverno, we're using Open Policy Agent to do a lot of our policy. So point that out.
Thank you.
By the way, in the bigger picture here, Google is very active in Salsa. I don't know how many people in the room are active over in Salsa. We very much want to help to up-level the standards across the industry here. That's part of why I'm giving this presentation. So you should feel free to reach out to me in our Slack. if you have questions or want more details, those kinds of things. I would also encourage you to take my scripts in that repo and stand up this demo yourself and go play with it, and think about how you might adopt something like this in your organization, whether it's on Google Cloud Platform or using other tooling. Binary authorization is going to be a little harder to find in other tooling right now, but.
So I have a quick question in terms of moving to the higher levels. I saw, does Google have a plan for in terms of how it's going to achieve that, or how I was thinking about that?
So I assume you're asking about that in terms of the public offering of binary authorization. Internally, we are beyond what's currently available in SALSA in terms of our internal binary authorization. Publicly, yes, our plan is to provide a path to enable our customers to gradually opt in to up-leveling their security. We'd like to get them to a place where they can be secure by default, which is the experience I have as an internal Google engineer. But that's obviously going to take some time, and I'll be honest, security causes some friction, right? And so that's why we're doing this opt-in terms of our Google Cloud Platform offering, and hopefully we're going to see more and more industry adoption of these kinds of standards and enforcement. So I'll just add a plug before I completely cede the floor here. And the plug is come to Google Cloud Next, and you can hear more about that last question of what we're going to be offering for our customers in this space.
Thanks for the presentation and demo, David, and thanks everyone for really great questions. So assuming we don't have any other questions, I want to go back to the next topic on the agenda, which is kind of a heads up about what's happening within the community, so we can look at that topic and look for ways to contribute to it. So recently, there has been some conversations within the community under the name CDF Reference Architecture, and this topic was presented to Technical Oversight Committee on July 19, if I am not mistaken. And then the topic was brought into governing board as part of its strategy session, and another discussion took place there. What this initiative is about, I'm not going to go through all these slides, but this initiative intends to bring all the work we have been doing under different groups, such as Special Interest Group, MLOps, interoperability, events, best practices, and software supply chain, and put them together to come up with a reference architecture that would give us organizations some kind of blueprint when it comes to how they can implement continuous delivery within their organizations. And I included slides on the HackMD document, so please take a look at the document. And why I am bringing this topic right now is because we talked about a similar thing in the past within our SIG, which we didn't call it reference architecture. We named it proof of concept based on the work done by Mike Lieberman and his friends at CNCF Technical Advisory Group Software Supply Chain. And that work creates a reference implementation architecture called Secure Software Factory, which is renamed to FSHCA, if I am pronouncing it right. So we were thinking of basing our proof of concept on that and trying to contribute to the efforts from continuous delivery perspective. But seeing the reference architecture work kicking off, the idea is perhaps we should look at what is happening within reference architecture initiative and align our efforts with that work, so we contribute to reference architecture from software supply chain aspects from within our group, instead of us going and creating yet another proof of concept or set of pipelines. And this work actually started this week, at least the conversations started this week within Special Interest Group best practices, and Terry created a branch on Special Interest Group best practices GitHub repository. Let me quickly show that as well to put the basics in place. If I can find the branch, no, maybe I'm looking at, was it website?
Best practices site other than the main repo.
Yeah, we can put the link to the HackMD, but this is the preview. So Terry, would you like to summarize what we have on the preview site?
Yeah, so basically what we're trying to do with this is to work downwards from the best practice work that we to date to try and bridge some of the conceptual gaps that are out there at the moment. So the first phase of the work really is to make it easier for people to understand how continuous delivery fits into business process and the structure and culture of the organization. And then once we've done that piece of work, we can then start to drill into some of the more specific areas of reference implementation and hopefully pull together a number of these pieces of work across the various special groups. So what we're creating is a narrative that helps people to connect all the dots and understand what resources are available and how to approach individual challenges.
Barry, are you open to someone skipping ahead a little bit and starting to define the architecture and then link back to these views and viewpoints?
Yeah, in fact, what we're intending really work is to do the classic sort of inverted pyramid on pyramid. So we're working from the top, a broad set of basic methodologies for continuous delivery, and bringing that down to a point which will be the reference architecture from the business perspective down. And what we're looking to do is, from a community perspective, say, here is a specific tool or a specific project, and this is how this project implements, best practice against the overarching methodology. So very open to having some of that bottom-up work being done in parallel, so that we can connect all these things together efficiently.
Thanks, Terry. And the best practices SIG meets every second and fourth Monday, I believe. Terry, is that correct? Second and fourth.
That's correct, yeah.
Monday, yeah. So if you would like to take part in conversations, please join those meetings. This is still at the early phases. I finally located the right repository best practice site, and the branch RefArch one is the branch where this preview is generated from. So, and the other thing to highlight here is, like, if you have like ideas around contributing different perspectives, please do that. Or if you have colleagues working on these different parts of the organization or different roles, please bring this to their attention so that we can bring their perspectives into this work as well. So,
I just did want.
Yeah.
I just did want to mention. So I think you brought up Fresca and an SN implementation of the CNCF, the architecture and best practices. So we would love to do a demo maybe next time. I think we can show that off and see how that kind of applies, and show off how exactly it's meeting all the best practices that the CF set forward, all the different components of it, and how it achieves all the different SALSA levels and up to SALSA level 3 and forward.
Cool. Yeah, I will then reach out to you to schedule a session presentation demo from Fushka. Next one is reserved, but we can think for the September one. Thanks a lot for that. So that actually brings the closing thoughts. So our next meeting will be on August 25th, and we have another presentation scheduled for that one. Please keep an eye on Slack channel and also CDF Twitter, which we will be announcing the upcoming presentation. And with that, I want to thank everyone for joining today. Thank you, David, for great presentation and demo. And I wish all of you have a nice rest of your day. Thank you very much.
Thanks, everybody.
Thanks. Bye.
Bye, everyone.
Everyone.